to talk about this and to deal with this slowing downness with bigger problems. Okay? All right. So what we're going to do is, first off, clear out our memory here. Oops, without all the capitals. That'd be great. All right. And we're going to go back down to 60. And I'm going to run this again, except I'm going to add spy A. There we go. So I'm going to add one more command at the bottom, which is going to be called spy, and you'll see what it does in a second. It'll be, I hope, fairly clear. And we're going to run that. So 60 by 60 happened fast. So the calculation's all been done, and I just added one last plotting at the end here. And this is what it gives us. So if we're looking at the A matrix, remember the A matrix is all the coefficients of the various temperatures. What do you think this little picture here is telling us about the A matrix? Go back to the second page of the notes if you want to, or third page of the notes if you want to see what goes into the A matrix again. Yeah? Which squares have non-zero values? Exactly. So look at that picture there for a second. And then we're going to go back in the notes. Way back up to here. Oops, too far. There we go. Remember how this matrix was built. This is the matrix of coefficients involved in the solving, blah, blah, blah. 3 elements down the diagonals, and then one off diagonal and one off diagonal that way. When we go up, that was the 5 by 5. When we go up to the 60 by 60, we get 3,600 60 squared elements in this matrix by 3,600. And we see that same banding. If we zoomed in, we'd see that narrow band in the middle is thicker. Let's see if we can do that just for a sec. Yeah, there we go. So you can see there's thin little bands here, and then these bands here are 3 by 3, mostly, except for those, hey, I got to the end of a row, so it's not adjacent to the one beside it, so we have these little holes of zeros there. Now, what that tells us is a few things. What is this matrix mostly made out of? If I had to pick one value randomly out of this pile, what would it be? 0. Right. There's a whole whack load of zeros here. In fact, the ratio of non-zeros to zeros is incredibly low. The information in here is all in those 3 bands, and everything else is a 0. Okay. That's an important note to make because zeros are nice. We like zeros when it comes to calculations. All right. Let's go back to where we were. There we go. Yeah. All right. So if we have roughly 5 entries per row, and that's what we saw. So this huge matrix here has the 3 bands and then that one. On average, there's going to be 5 entries per row. That's 5 out of 3,600 entries in every row. So less than 1%. It's actually closer to around 0.1% are non-zero. So that's a lot of zeros that we're storing when they're just zeros. They're not that interesting. Okay. So that begs the question. So maybe we can figure some way to take advantage of this structure. And that's what we're going to look at next. Trusses and the heat distribution problem. So if we go back a couple weeks to where we had connections of joints, those are all based on connectivity. What am I next to? What am I attached to? And by and large, each individual thing, like a beam and a truss, is only going to be attached to 2 joints. Each cell in the temperature matrix is at most adjacent to 4 other things. So in general, there's not a lot of connectivity, even though there might be a lot of things to connect. And so what we get here is that the number of non-zero elements is going to be very small. Right? Most of the matrix of coefficients is going to be zeros, and only a few things where things are connected do we get some non-zero interesting values.